So, what's the pattern for this warm-up? Not times 5, but we're multiplying by 2, right? Every single time, we're multiplying by 2. Every time you go to the next number, you're multiplying by 2 to get to the next number in the sequence. And this is exactly what a geometric sequence is, and that's what we're going to learn today. A geometric sequence. But instead of just seeing a pattern, you may go from one number to the next, we're going to be writing formulas that describe those patterns. So a geometric sequence is a set of numbers with a ratio of any term to the previous term is a constant. These can be written in two different forms, explicitly or recursively. So that definition of a geometric sequence is kind of confusing. If you look at the example we used before, of 3, 6, 12, 24, 48, it is saying we divide the previous term with one before it, it gives you the same number. 6 divided by 3, that's 2. 12 divided by 6, that's also 2. 24 divided by 12 is also 2. You take one number and divide it by the number right before it, it should always give you the same number. Or in other words, you multiply by that number, you go to the next term. And that term is called the common ratio. That's your R that you multiply a term with to go to the next number in that sequence. So an explicit formula, that's like the name says, it's a formula to give you the explicit term of any number in that sequence. So if we look at the sequence we just looked at, 3, 6, 12, 24, and 48. If we're going to label each number in that sequence a number, so like if you say 3 is f of 1, 6 is f of 2, 12 is f of 3, 24 is f of 4, and 48 is f of 5. Or it's like the first, second, third, fourth, and fifth number in that sequence. The explicit formula will tell me any number that I want in that sequence. So if I want to know that the 155th term of the sequence, I can plug in 155 for n, and I can figure that out in the explicit formula. And the explicit formula of f of n equals f of k times r of n to n minus k. What that's saying is that f of n is the nth term in the sequence. F of k can be any term in the sequence. It doesn't matter which one. And r is the common ratio, or how you're going from one number to the next. So this ratio, we saw that we multiply by 2 each time to get to the next number. That tells me that r is 2. That's your common ratio. And this f of k can be any number you want in the sequence. So if I look at this pattern we saw in the warm-up, the explicit formula for that one, that's just going to be f of n will equal any f of k you want, so f of 1, 2, 3, 4, 5, you have those. It doesn't matter which one, but it's usually best to use the first term in sequence. So say f of 1 multiplied by r raised to the n minus k. I don't know what n is, n can be anything, and my k we said is going to be 1. So you plug in your r and your f of 1. The explicit formula for that sequence is f of n equals f of 1, which we said is 3, multiplied by r times n, or r to the n minus 1, or sorry, r to 2 to the n minus 1. I just decided to take a 1. You can make any term you want to. F of k can be any term in sequence. If you wanted to, you could say, well, I want f of 2. And then instead of 3, you'd have that 6. Because 6 is f of 2. It doesn't matter as long as it's some term, but you have to stay consistent with that k value. It's n minus k. If you use f of 2, it's now n minus 2. So that's fine. Yeah, it's not too bad. It can be a little confusing at times. It's not too bad. Yeah, that you won't really use it. Even this here, you use it once, but 13.1. All right. So now there's also something called the recursive formula. The recursive formula is a formula for a geometric sequence, but told recursively. Recursively just means it depends on the terms before. So the recursive formula will be r times, or f of n will equal r times f of n minus 1. And the difference with the recursive formula is you need to know what the initial term is. Because it depends on the terms before it, you need to know what f of 1 is going to be. So if I use that same sequence you just saw, the 3, 6, 12, 24, 48, in this case, f of n, which n can be any number that I want, will equal r, which we said is 2, times f of n minus 1, which I don't know what it is, depends on what n is going to be, given f of 1 is 3. And that's really all it is. Well, what f of n minus 1 will be will change depending on what you're trying to find. If I want to know, like, the fourth term of the sequence, like f of 4, I just plug in 4 for n, so it's 2 times f of 4 minus 1, when f of 1 is 3. Well, f of 4 minus 1 is f of 3. F of 3, you said it's 12. So f of 4 would be 2 times 12, or 24. And that's exactly what it is. Does that make sense? Oh, this one right here? This one is saying given that f of 1 is 3. Because it's a recursive formula, which means it depends on what's happening before it. So you need to know where it's starting from. To be able to have a recursive formula, you have to know where it's starting at. So we're starting at f of 1, which is 3. So this part right here, this f of 1 equals 3. That's just kind of saying, well, this is the formula, 2 times f of n minus 1, but the first term is 3. That's all it's saying. But when you're actually solving for an actual term, I don't really care for it too much unless you have to work all the way back, which I don't know.
So would you plug in the 3?
The f of 1 equals 3? Yeah. No, I didn't plug that in because there's no point. So f of 1 equals 3, that's just your initial term, where the whole sequence is starting. So right here, the sequence of 3, 6, 12, 24, and 48. F of 1 is 3. Started at 3. In a recursive formula, will tell you the certain term depending on the term right before. Because I made an example, I'll say, well, what's f of 4? So when f of n equals 4, right? So f of 4 will equal 2 times f of 4 minus 1. So n minus 1. So 4 minus 1 is 3. What's f of 3 in the sequence right here? 12, right? So 2 times 12, or 2 times the term right before it is 24. F of 4 is 24. Because it's 2 times f the term right before it, right? So remember our sequence here, the term here, or the sequence here is you multiply by 2 each time, right? So the recursive formula is basically just saying, well, how do you go from one term to the next? You multiply it by 2, right? That's all it's saying. Well, 2 times, to find like what f of 4, you multiply 2 with the term right before it, f of 3. So you go to figure out what f of 4 is, you multiply 2 with f of 3. So you multiply by 2 to get to the next term. That's what recursive means. It depends on what's happening before. Now if you ask you for the recursive formula for it, and we're going to see some examples where we work it out, yeah, you will get points off for not putting f of 1 equals 3 because the recursive formula, it depends on where it starts. If you don't know where it starts, you don't really have a recursive formula. Does that make sense? Right? Sorry? N was greater than 2? Like the explicit or the recursive? Oh, this is n is greater than equal to 2 because you can't really figure out f of 1 is, right? If I say, well, what's f of 1? That's going to be 2 times f of 1 minus 1, right? Well, what's f of 0? Do I have an f of 0? I don't have one, right? So this whole thing of n being greater than equal to 2, that's there just to tell you that you need to have your first term. You have to know what f of 1 is, but after that, you can figure out any term you want to from the recursive formula from f of 2 on. Because my pattern starts at f of 1, then goes to f of 2, 3, 4, 5, 2, and 6, right? So we get the n is greater than equal to 2? I don't think so. Probably not. The most important part is saying f of 1 equals whatever. And it's probably better to put n is greater than equal to 2. Any other questions here before we move on? and R is a common ratio. R is a common ratio. The common ratio can be found by dividing any terms of the previous term or just the number you're multiplying with, the scale you're multiplying with, so the next. All right. So now we have a new sequence of 7, 21, 63, etc. We're going to find the following. Write an explicit formula. So before I write my explicit formula, I need to figure out, well, what's my R going to be? It's 3, right? You go from 7 to 21, I multiply by 3. From 21 to 63, I multiply by 3. And we're going to keep going with that path. So right away, I know that R equals 3. So my explicit formula, that's f of n, will equal f of k, which would be any term in the sequence that you want, multiplied by r raised to the n minus k. That's the explicit formula. I'm just rewriting it. And now I'm just going to plug in f of k in my r. So f of n, well, that's what that's the general formula for the explicit formula. So we'll just see f of n equals some f of k. It doesn't matter which one. So if you want to use an f of 1, that'll be 7, multiplied by that r value of 3 to the n minus 1. Well, f of n is what you're looking for. So we're trying to say, like, it's a general case. Well, what's f of, let's say, like 27? In that case, you plug in n equals to 27 here, plug it in, you can solve for the 27th term of the sequence. K is the actual, like, specific value you're going to plug into a formula. Well, n is more like a general case. Well, what can happen at any value that I want? Like f of x, right? You plug in x times x. Go ahead. So you can do that too. So let's see what f of n minus 3 looks like. So in this case, we're going to do f of, we're going to use a k value 3. So f of n, we'll do 2 actually. It'll be a little easier. So f of k, so we'll see f of 2, right? Well, what's f of 2 in the sequence? 21, right? So it'll be 21 multiplied by my r value 3 raised to the n minus 2. So nothing really changes. So in this case, if I wanted to find like the 27th term, you do the same thing. F of 27 equals 21 times 3 to the 27 minus 2, or 3 to the 26th power. Does that make sense? So it's the same thing. Now write a recursive formula. A recursive formula, that's going to be one where f of n equals r times f of n minus 1 when n is greater than or equal to 2. So I have my r value, that's just going to be 3. So f of n will equal 3 times f of n minus 1. I can't really plug in n minus 1 there because I don't really know what I'm looking for. Or really a better way to say it is that I want to have the general case to solve for any term that I want. And I see to plug that f of 1 is 7. So I want to put what the general case is going to be so I know where I'm starting so I can solve for every single term that's here. And then from here, I can just say when n is greater than equal. I think it's probably better to say that. Always put the n has to be greater than equal. Does that make sense? Okay, good. All right. So now we're going to find the 6th term in the sequence. So anytime we ask you to find like the 6th term in the sequence and you don't know what's right before it, it's almost always going to be best to use the explicit formula. Because the explicit formula will tell you, explicitly what that term is going to be, and you just plug it in. And it doesn't matter which one we use because here we have 2 equations, right? We made 2 of them. They both will work. So for the first one, I want to figure out what f of 6 is going to be. That's going to be 7 times 3 to the 6 minus 1. So f of 6 equals 7 times 3 to the 5th power. 3 to the 5th power, that's 243, I think. Yeah, 243. So f of 6 equals 7 times 243, which is 1701. Are you okay with that? All right. If I wanted to use the other one, as the f of n of 21 times 3 to the n minus 2, if I want to use this formula instead, you'd still get the same answer. So f of 6 with that formula will be 21 times 3 to the 6 minus 2. F of 6 will equal 21 times 3 to the 4th power, or 21 times 81, which is still 1701. There you go. Another way to see this part right here is that isn't this the same thing as 7 times 3 times 3 to the 4th, which is 7 times 2 to the 4th, which is the exact same thing we have here. So they're all related, they all give you the same thing, they all work. That's what I'm trying to say. Does that make sense? Kind of. So I just use the other formula. So I made two formulas here, two explicit formulas. So the 21 is the explicit formula when I use the k at the same time. Yeah, I use both.
I thought you used recursive.
No, I'm like, no. There's no point you use the recursive. I don't know if it's term, right? So it's kind of hard to use. You have to use the recursive formula like 2 times or 3 times before you have to have. Any questions here? Are we okay? All right, let's keep going. Or is anyone still talking? Yeah, these are both explicit. So I just want to use both formulas to show you that it doesn't matter which explicit formula you use, you get the same thing because it just gives you the same work anyway. You see that? That's why. Ready to go? All right. So now I want to figure out what f of 5 is if f of n equals 3 over 2 times f of n minus 1 and f of 2 equals 8. So this looks just like a recursive formula, right? F of n equals 3 over 2 times f of n minus 1, where f of n minus 1 is just the term right before f of n. Y'all see that? Make sense? So just saying I'm multiplying the previous term with 3 over 2 to get to the next term. So what's that r going to be? R is 3 over 2, right? So this right here is my r value, because the recursive formula is f of n equals r times the previous term right before. So r is 3 over 2. And then from here, you could make an explicit formula out of it if you wanted to. You could say, well, the recursive formula is f of n equals f of k times r to the n minus k. I know here that when k is 2, f of k is 8. So I could plug that in and say, well, f of n equals my f of 2, which is 8, times r, which is 3 over 2, raised to the n minus 2. So I could make an explicit formula out of it, and I could work this out and solve it out that way. So I could say, well, now I want to know what f of 5 is. So f of 5 equals 8 times 3 over 2 raised to the 5 minus 2, which is 3. Right, with n is 5, 5 minus 2 is 3. And then I'm just going to distribute this 3 to top and bottom and solve it out. So I get that 8 times 3 to the 3rd power is 27, all over 2 to the 3rd power, which is 8. The 8's cancel out, and I'm just left with 27. Go ahead, Maggie. To be honest with you, recursive formulas for geometric sequences I think are very kind of bad. Recursive, there are important things that come to recursive. Like there's recursive sequences, those are really important. Like y'all heard of the Fibonacci sequence? That's a recursive, not a geometric sequence, but a recursive sequence. The recursive stuff is important. So I think when it comes to geometric sequences, finding recursive formulas is kind of important. So they're important, just not with geometric. All right. Another way to solve this one is that instead of going through all this work and putting into an explicit formula, because I just want to know what f of 5 is going to be, that's a pretty small number, I can just figure out what f of 5 is going to be by following the path. So I have f of 2, f of 3, f of 4, and f of 5, right? F of 2, I know is 8. And I know that my r is 3 over 2, right? I can just multiply 8 with 3 over 2 to get to the next term. 8 times 3 over 2. 8 divided by 2 is 4. 4 times 3 is 12. Or I'm going to just multiply by 1.5, right? 12 times 3 over 2. 12 divided by 2 is 6. 6 times 3 is 18. And same thing here. Multiply by 3 over 2. 18 divided by 2 is 9. 9 times 3 is 27. It's the same exact thing. They both give you the same exact thing. Because that's what a geometric sequence is. You just multiply by an r to get to the next one. Are you okay with that? They both work. They both do the same thing. They're just it's the same thing, just different. All right. So example 3. Given f of n is a geometric sequence where f of x equals 25 and f of n equals 200, find f of 4. All right, so the first thing I'm going to do is just write out my sequence. I know that f of 6 is going to be 25. I don't know what f of 7 is. I don't know what f of 8 is. And I don't know what f of 9, or I do know what f of 9 is. That's 200. Right? So to go from 25 to 200, I have to multiply by r 3 times, right? So I know that 25 times r cubed equals 200, right? Does that part make sense? I wrote it out, and I know that a geometric sequence, you're going to multiply something by a term r to get to the next term. So 25 times r gives me f of 7. 25, or f of 7 times r gives me f of 8. F of 8 times r gives me 200. Or in other words, multiply 25 3 times r to get 200. Or r cubed equals 200 over 25, which is 8. So r cubed equals 8, which is just, sorry, it's not r cubed, r equals 8. Sorry, r cubed equals 8, so r is 2. There we go. Does that make sense? Everyone with me? Right? So f of 6 is 25, right? So how do I go from f of 6 to f of 7? What do I multiply by? By r, right? I don't know what r is yet, but I'm multiplying by some common ratio of r, right? So 25 times r gives me 27. So that will be 25 times r, right? And then 25 times r goes to the next term. So it's 25 times r, right? And then 25 times r times the third r gives me 200. Or in other words, 25 r cubed gives me 200. And then we can solve for r. Yeah, it's the same thing, right? You put the formula.
Be sure outdoor one game wise you feel like this. Yeah, I was trying doing it like this.
I mean, you can do the formula if you wanted to, like we do it outreach check. So the explicit formula is
Not for this one.
for, yeah, so do I, that's why I do it this way. It's easier, right? So f of n equals f of k times r to the n minus k, right? Plug in n and k into here, so f of 9 is 200 equals f of k, which is 25, times r to the 9 minus 6. So this is the formula. I plug in f of 9 for n, I plug in f of 9 here, and f of 6 for k. I got this, and you get the same exact thing, right? 200 equals 25 r cubed. It's the same exact thing. Is that for me, I'd rather draw something out like this and kind of see what's happening with my own eyes rather than just plug into a formula and not understand what's happening. So you're right. It makes a lot more sense to just draw something out like this, right? Any questions here? Are we good? All right. So I need to figure out what f of 4 is. I have my r, so I have my explicit formula. Once you have your r, you're pretty much set. So my explicit formula is f of n equals some f of k term. And let's use f of 6, because that's just 25. Multiply by my r value, which we know is 2, to the n minus 6. So f of n equals f of 6, which is 25, times 2 to the n minus 6. So now I want to figure out what f of, I think it's 4, right? Yeah, f of 4 is. So just plug in 4 for n. F of 4 equals 25 times 4 minus 6. So it's 2 raised to the negative 2 power. So what happens when you have an negative power? Yeah, you flip it, you make the reciprocal for it. So it becomes 25 over 2 squared, or 25 over 4. And that's your answer. Is everyone with me so far? Make sense? Yeah, stuff isn't too bad. It just can get a little confusing, a little overwhelming at first. Anyone start copying? Ready to keep going? Ready? All right. So example 4, given the following sequence, I want to write a recursive formula, an explicit formula, and I want to find the 13th term. So I can't really write a recursive formula without f of 1. You need to know where the sequence starts to figure out the recursive formula. So what I'm going to do is I'm going to figure out what my r is going to be, and then I'm going to figure out what's my f of 1 going to be. So in this case, if I look at it, I can see that to go from 25 over 24 to 5 over 4, I'm going to multiply it by r 2 times, right? So I know that 25 over 24 times r squared is 5 over 4. Everyone with me? So I multiply 25 over 24 by some r term that I don't know what it is. 2 times it to 5 over 4. So from here I can multiply both sides by 24 over 25. To cancel out that 25 over 24 on the left side. These cancel out. And I'm left with r squared on the left side. And on the right side, the 25 and 5 reduced down to 1 and 5. 24 and 4 reduced down to 1 and 6. So r squared ends up being 6 over 5. Everyone with me? So r squared is 6 over 5. So r is going to be the square root of 6 all over the square root of 5. But I don't want these square roots in the bottom. So I can multiply top and bottom by root 5 to get that r equals the square root of 30 all over 5. That's what my r value is going to be. It looks a little ugly, but that's okay. So now I can write a recursive formula. But to figure out my recursive formula, I need to know what f of 1 is going to be. So if I look at this sequence again, I know if I take 25 over 24 and divide by r 2 times, I get f of 1, right? So I know that 25 over 24 divided by or multiplied with 1 over r squared equals f of 1. Okay, yeah. Well, I don't know what f of 2 is, right?
Oh.
So I'm going from f of 3, right? 25 over 24 is f of 3. So I'm dividing it twice to get to f of 1. Or in other words, dividing by r is the same thing as multiplying by 1 over r. So it's 25 over 24 times 1 over r squared. No, that's f of 3, yeah. All right, now I'm going to solve for f of 1. I know r squared is 6 over 5, right? So 25 over 24 multiplied by my r squared, which is 6 over 5. So 1 over 6 over 5 is the same as 5 over 6. And that equals f of 1. When you multiply these together, you get 125 over 144. Yeah, 125 over 144. So that's f of 1. Everyone with me? Are we good? Sorry? All right. Do you get how we set this part right here up? So I have 25 over 24, right? And I want to know what f of 1 is. Because remember, recursive formula, you need to know what f of 1 is. You need to know where you start. So to go from 25 over 24 to f of 2, you go one term before, what do you do? By what? By r, right? So go from f of 2 to f of 1, what do you do? Divide by r again. You go from 25 over 24 to f of 1, divided by r twice. Yeah, so dividing by r is the same thing as multiplying by 1 over r squared, right? That's where I got this part right here at the start. Does that make sense? And then from here, I know what r squared is. I plug that in, and I solve. So from here, I'm going to figure out my formula. My explicit formula is going to be f of n equals my r value of the square root of 30 over 5. That's what r is. Multiplied by f of n minus 1. That is just the regular formula for the explicit formula, or the recursive, sorry. When f of 1 equals 125 over 144, when n is greater than or equal to 2. So all this right here is your recursive formula. You have the actual formula, and you have the limits for it, saying where it starts and what n can actually be. Does that make sense? Any questions there? All right, now we're writing an explicit formula. That one shouldn't be too bad because I know what certain terms are, and I also know what f of 1 is going to be. So my explicit formula, well, that's just f of n will equal my r value of the square root of 30 over 5, multiply or raised to the power of n minus k, or let me back up, sorry, do f of k first. So f of n will equal f of k, where f of k is any number in the sequence. So we can use 5 over 4 because it's a little small. So I'm going to use 5 over 4, which is the 5th term in the sequence. So multiply by r, my r value of the square root of 30 over 5. What are you lost about? All raised to the n minus 5. Does that make sense? I decided to use the 5th term instead of like the 3rd term because the 5th term is just smaller numbers, a little easier to work. So now I want to figure out what's the 13th term in the sequence. So that's going to be easiest to do with the explicit formula. So f of 13, that's going to be 5 over 4 multiplied by the square root of 30 all over 5 raised to the 13 minus 5. All right? So f of 13, that's going to be 5 over 4 multiplied by 30 is just 30 to the 1 half, all over 5 raised to the 13 minus 5. I change the square root of 30 to 30 to the 1 half so I can deal with all the exponents. Distribute in this 8, and I get 5 times 30 to the 4th power all over 4 times 5 to the 8th power. Are you good so far? Any questions?
Wait, how do you get 4?
Sorry?
How do you get
4, 5 and 4? Got it? All right. So now I change everything to its prime factorization so I can cancel stuff out if I can. So 30, that's going to be 3 and 5 and 2, right? 3, 5, 2. So 3 to the 4th times 5 to the 4th times 2 to the 4th. 4 is 2 squared, so 2 squared times 5 to the 8th. Are we good so far? So I'm going to start canceling stuff out. I can get rid of these 2's on the bottom and change this 2 to the 4th to a 2 squared. I have a total of 5 2's on the top, or sorry, 5 4's on the top. I can cancel these out with the 8 on the bottom and be left with 3 on the bottom. So what I'm left with is 3 to the 4th on the top, which is 81 times 4, which is 324. All over 5 to the 3rd, which is 125. Which way?
There's the 30 and 4. How do you break it down? Like, do you put the
3 to the 4th?
Yeah.
I didn't break it down.
how do you get from 30?
Oh, so 30?
Yeah.
The prime factorization of 30 is 5 times 2 times 3, right?
Yeah.
So, yeah, so this 30.
You just left on the 4.
Yeah, because it's 30 all the way to this, right? So I can say, well, 30 to the 4th is the same as all of this to the 4th power. Gender distributed.
They all got 4.
Yeah, they all got 4. Are we good? Any questions here? We got one more problem, guys. We got one more. Sorry? So I have a 5, right? I get 5 to the 1st power and 5 to the 4th power, right? So that's 5 to the 5th power, right? On the bottom, 5 to the 8th. When you combine them, they cancel out. They cancel out. Any questions here, guys, before we move on? Are we good? All right, one more problem. That one is not going to be too bad. All right. Yes.
What is that?
This one? I'll show you to Steve how we broke 3 to the 4th, 3 to the 4th, 5 to the 4th. All right, guys, put it down. There's one more problem. All right. So here I'm told f of n, if f of n equals 125 times f to n minus n plus 3, we're going to find the common ratio r. So I only want to find what r is going to be. So here we could go ahead and just make another chart here. So f of n plus 1, f of n plus 2, and f of n plus 3, right? And I don't know what any of these are, but what I do know is that it goes from f of n plus 3 to f of n. I multiplied f of n plus 3 by 125. So we go from here, from f of n plus 3, some x value right here, to here, and then to here. I multiply each time by r. Because remember, a recursive formula is based on what's before it. But this is not a recursive formula because it's telling me f of n is based on what's happening after. That's not a recursive formula, right? Excursive. Yeah, I've never heard of it before, but sure. Excursive. Sorry? Good? So I'm kind of going backwards and I'm dividing by r each time. That tells me that 1 over r cubed equals 125. Does that make sense? Are you good with that? Right? Because I'm dividing it, right? Because I'm dividing f of n plus 3 to get to f of n. You divide f of n plus 3 by 125 to get to f of n. Or sorry, the other way around. You multiply f of n by 125. Because remember, dividing by r is the same as multiplying by 1 over r, right? So then we divide by r 3 times, it's the same thing as saying, well, it's 1 over r cubed. Are you okay with that? Here's another way to see it, is if I decide to take this formula right here, guys, keep it down, please stop hitting each other. So another way to see it, if f of n equals 125 times f of n plus 3, right? So remember, I don't ever want, with the recursive formula, I always want the smaller number by itself. I want f of n plus 3 by itself. So I could write it like this. Does that make sense? And then this is 3 times as big, right? It's 3 times. We're multiplying by 3 times. So if you look at it the other way, you go from f of n to f of n plus 3, we went over by r 3 times, right? So you multiply f of n, you multiply f of n by r 3 times to get f of n plus 3. So r cubed equals 1 over 25. Does that make sense, Thomas? Are you okay with this, or not making much sense?
Wait, but then f of n plus 3 is equal to 125.
This is equal 125. But I multiply f of n by 1 over 25 to get to f of n plus 3, right? I don't know what these values are. But if I look at the chart from f of n plus 1, n plus 2, and n plus 3, you go from f of n to f of n plus 3, you multiply by r 3 times, right? So f of n times r cubed is f of n plus 3. So this is 1 over 25, that is r cubed. That's okay. Geometric sequence, all it is that you multiply by a certain r value goes to the next term. So it doesn't matter if it's bigger or smaller as long as you follow that pattern. But you're right, f of n would be bigger than f of n. Are you okay with this? Well, it's like I go from like 100 to 50 to 25 to 12.5. You multiply by a half each time, right? That's a geometric sequence.
Aren't you multiplying to get to f of n?
You are, but if you multiply by a fraction, it gets smaller.
Oh, yeah.
Right? So in this case, r is going to be 1 over 5. So the important thing here to know is that you have to put your stuff in order from smallest, not smallest, but the first term to the last term. F of n goes first, f of n plus 3 comes after f of n. So a lot of times it is worth it to kind of drop this chart right in the top, this little diagram of what's happening, see exactly how you get to the next step.
How would you solve the first one?
Sorry?
The first one is right.
This one right here?
No, the
Right here? Oh, you can multiply both sides by r cubed. You get 1 equals 125 r cubed, or 1 over 125 equals r cubed. It's the same thing. I know it's a long lesson. that make sense? Any questions, comments, concerns, complaints?
Not for now, Josh.
After that?
Not for now.
Not for now.
You know,
I don't think it gets a little easier. So it doesn't get too much work.